Thousands of trains switch tracks at railway junctions every day without a hitch. By the end of this video, you'll know the key parts of a railway junction and how they all work together to keep the trains running to the correct places. From the switch panel to the crossing panel and beyond, I'll break a junction down and explain what each part does. Let's get started. Railway junctions, no matter their size and complexity, all have the same functions. Junctions are where two or more tracks meet and allow trains to switch between tracks and routes. Being able to switch tracks ultimately allows a train service to be run by giving access to different routes, the ability to have multiple platforms at stations, change the route of trains to manage traffic, and many other important factors. Junctions can vary in complexity, from a single turnout up to fiercely complicated layouts found in places like the approaches to main stations. But no matter the complexity, the basic parts are the same. First up, we have the switch panel. Within the switch panel is one of the very few places on the railway where the rails are actually designed to move. To determine which route a train takes, the switches move, allowing one of two routes to be taken. That is a key point to remember when it comes to junctions. With multiple routes, each switch allows a choice of two routes. Sets of switches themselves are made of two rails. There is the stock rail. This is the full profile rail that connects into the plain line at the front of the switch panel. The other rails are the switch rails. The switch rail's purpose is to transfer the train wheel from one rail to the other, and they have a varying profile to help achieve this. The key thing you'll notice about the switch rail is that they are free to move at one end, known as the toe. These are the movable pieces of rail that move back and forth and allow a route for the train to be selected. The gap or gauge between these movable pieces of rail is maintained through the use of stretcher bars. I have a whole playlist dedicated to switches and crossings videos. So if you want to know more detail on anything covered in this video, jump across to that playlist and I'm sure you'll find your next video to watch. So what makes these rails move when a signaller wants them to? This is the points operating equipment, or POE. There are a number of types and designs, but they all do the same thing. They move or throw the switches to one of the two positions they could be in, normal or reverse. At the simple end of the spectrum is the manual hand point. To throw these switches involves pulling a handle connected directly to the switches themselves. You'll most commonly come across these type of POE in sidings now, as they are not suited for use in high traffic areas given their very manual nature. The other more modern versions of POE involve some sort of motor or drive, be that electrical or hydraulic, that move the points at the request of the signaller or signalling system, along with some way of locking the points in position to allow trains to travel across the switches safely. Types include point machine, clamp lock, HPSS, high drive. It is through the POE and the sensors attached to it that these switches, and by extension the junctions, become integrated into the wider railway signalling and control system. After the switch panel, the next biggest thing you'll notice at a railway junction is the crossing. It's a large and distinct piece of metal that could be made from a single casting or multiple pieces of machined sections bolted together, or a hybrid mix of both. The line speed and usage of a particular track will determine which crossing construction type is used, with the cast crossing being used in the higher speed and usage lines. The crossing's role is to allow the train wheel to pass through another rail, which leads to a small gap in the otherwise continuous running surface of the rail. The wheel transfers from one side of this gap to the other, travelling across the crossing nose. The nose is profiled to pick up the train wheel, but this also makes it vulnerable to damage. The number of crossings you'll find in a junction layout is very much driven by the layout itself. A single turnout, where there is one line diverging into two, has a single crossing. Double junctions can have 6 crossings. And then you have somewhere like this, where you can lose count quite easily. Where does one layout finish and the next one start? If you're interested in the different layouts of junctions you might come across, check out this video in the top right. In it, I'll walk you through a range of standard junction configurations. Within the crossing panel, you may also notice some other additional rails that are definitely worth mentioning. These are check rails, which help guide the wheel through the transfer process and also stop the crossing nose from taking a battering. They are placed either side of the crossing, on both routes, and are often not given the attention or credit that they're due for their importance. Now, those are the three main parts of a railway junction. There is an additional panel, known as the closure panel, that sits between the switch and crossing panels. This will have plain normal rails on it, but 4 of them, and tie into the panels either side. It is also worth noting here that one of the other main features of a junction that may jump straight out at you is the long sleepers, known as bearers. With the diverging routes and all that, you cannot use standard sleepers. Bearers are extended in length to hold multiple rails across 2 or more tracks. They also tend to be wider to take the extra load and other forces present at junctions. So, we have explored the switch and crossing panel, and then looked at the POE that moves the switches when required. I've explained the crucial role check rail plays, and pointed out the reason bearers are used rather than normal sleepers. Do not get me wrong, there are a number of other components that are needed to make a junction functional, but now you can recognise the main parts. Check out my S&C playlist to find out even more. If you found this breakdown helpful, make sure you like this video and share it with anyone else curious about the railway. And don't forget to subscribe for some more insights into the world of railway engineering from the PWay engineer.